All right, so in this lesson today, we're going to talk about the section 10C on the textbook. So this is our final section of the final chapter of this unit of trigonometry, and we're combining all the knowledge that we've learned in terms of the trigonometry as well as the 3D, points and space, and yeah, everything together. So let's get into it. We'll solve two example questions, and then we'll try the problems that are assigned in each classroom. First question, find the angle between the line segment EC and the base plane ABCO. So, well, the first thing that we need to think about is we need to find the coordinates of all the points. I guess we need to find the coordinate of E as well as the coordinate of B. And then we want to find the angle between the line segment and a plane. So let's do the easy stuff first. I'm first going to find the coordinate of E. How will I do that? Well, first of all, I need to know the x, y, and z coordinates. And because E seems to be on the x, z plane, it means that the y value will be 0 for sure. And then it seems to be directly above the point A, which means that it shares the same x coordinate, which is going to be 5. And then finally, the z value seems to be on the same level as the point D. So it's the z value will be 3. So I know that the point E is at 5, 0, 3. I think we can also find point B, although it might not be necessary. Point B seems to be at 5, 4, 0. So now, what do we need to do? Well, in order to find the angle between a line segment and a plane, well, initially the thought is that we can't find the angle between a line segment and a plane, right? So instead of finding the angle between the line segment and a plane, I'm going to find the projection, the line of projection of EC onto the plane ABCO. So once again, like I said multiple times in classroom, finding the projection of the line segments onto the plane, you need to imagine that you take a ladder from the base point onto the point E, and then imagine that you drop down to the plane and see where you land. So we can try to connect the point EC to find the line segment EC. And then imagine that you climb the ladder from C and you go up the hill up to the point E and then you drop. If you suddenly drop, then it means that we land onto the point A. So let's find the line segment AC. Now I'm going to find the angle between the line segment EC and the line segment AC. And I know that if I find such angle, then the angle will be the angle between the line segment EC and the base plane ABCO. So let's try to redraw this diagram because, seeing a 3D diagram is quite complicated. I know that my goal will be to find the angle theta in this triangle AEAC. Well, in order to find such angle, well, I'm going to need some kind of measurements. I need to find the length of EA, and I need to find the length of AC, and then maybe I need to find the length of EC. Well, we can think about multiple cases, but let's think about the easiest case. I think the length of EA is the easiest to find. That's going to be 3, simply the height of this rectangular prism. Then what's the next easiest step? Well, finding the length EC seems a bit tricky. I mean, we could just plug it into the formula and just be happy about it. But I think finding the angle, the length AC is a bit easier because, well, it's on the same plane, so we just need to do a simple 2D Pythagorean relationship. So let's find length AC by drawing another triangle. I'm going to draw the triangle ABC. In order to find the length AC. So I know that the triangle ABC has the legs of 4 here and a 5 here. And let's find the length AC by doing the Pythagorean theorem. square root of 4 squared plus 5 squared. 4 squared is 16, 5 squared is 25. So 16 plus 25 must be 41. So I know that the length AC is square root of 41. And now let's write the number at the length AC. So can I use these two measurements, the length of EA and AC, to find the angle theta? Well, obviously, by using the tangent ratio, knowing that the tangent ratio is given as the opposite over adjacent. In the perspective of this angle theta, the opposite has a length of 3 and the adjacent has a length of square root of 41. So doing the arctan on both sides, or in other words, doing the tangent with a -1, or inverse of tangent. And let's use the calculator to approximate this value into 366. In this question, by the way, the question does not tell you which unit to use, and it doesn't tell you any indications of which unit to use. So I think we need to stick with the radian measurement, obviously. So make sure that your mode is set in radian when we do the arctan of 3 divided by square root of 41. And my answer seems to be approximately 0.438 radian in 366. So once again, the method of my solution here, my thought process, is that I attempt to find a right angle triangle within this 3D diagram, and then use that right angle triangle and the ratios that we know of to solve the problem. Let's move on to the next problem. Example 4. Given points P, Q, and R, find the measure of the angle PQR. So we have these 3 points, and they are in 3D. So if I were to draw the XYZ plane and then attempt to plot the point P, Q, and R, it's near impossible. And it takes a lot of effort and time, and the point of this question is that we don't need to do such a thing. I can just randomly suppose that, hey, we have this imaginary, invisible XYZ axis, and let's just say that point P is here, and the point Q is here, and the point R is here, randomly. Of course, it'll be a lot better if I know exactly where these are, but we don't need to. At least for the purpose of this diagram, we don't need to draw the precise diagram to represent where these are. But what is our goal again? Our goal is to find the measure of PQR, which means I'm going to find the angle PQR, angle theta. Well, how will I find that angle? Well, just like how I did here, I connected all the points with the edges, with the lines, and we have formed a triangle. And my goal is to find one angle of the triangle. Then what are the ingredients that I need? Well, first of all, I do not know whether if this triangle is a right angle triangle or a non-right angle triangle. So I'm going to assume the least and say that this triangle is a non-right angle triangle. And we know the 2 rules of the non-right angle triangles. 3 rules. 1, the fact that the angles add up to 180 degrees in a triangle, or add up to pi. And also the fact that we know the sine rule and the cosine rule. And the sine rule, if you think about it, it involves use of 2 angles and 2 sides. And then the cosine rule involves one angle and three sides. In order to use a sine rule, we need two angles and two sides, so it means that we need another angle, which is counterintuitive. Right? It's logically, it's impossible. So therefore, the only option that we have left is the cosine rule. Well, cosine rule is easier to use in this case because we do know that, well, we need to find the angle, so we need to know three sides, or the length of three sides. And we happen to just have learned the formula that we need to find the distance between the 2 points in 3D. Right? The formula that we know of from the formula booklet is D is equal to x1 minus x2 squared plus y1 minus y2 squared plus z1 minus z2 squared. Once again, you know this formula from the formula booklet, so you don't need to memorize. But I do suggest that you copy it down on your notebook before you get started. So we just need to do this one by one. First thing, I'm going to find the distance between the point P and Q. Let's find the distance between point P and Q, which is going to be square root of, well, let's assume that P is the first point and Q is the second point. So it's going to be 1 minus negative 2 squared plus 4 minus 0 squared plus 5 minus 1 squared. And that's going to be square root of 1 minus negative 2 is 3. 3 squared is 9. 4 minus 0 is 4, so 16. And then 5 minus 1, 4, so plus 16, which is going to be square root of 9 plus 32, square root of 41. So apparently the distance, the length of the line segment PQ is square root of 41. Now let's repeat the process. Let's find the distance between P and R. Same thing, we just need to plug in the values. 1 minus 0 squared plus 4 minus negative 2 squared plus 5 minus 6 squared, which is going to be 1 plus 4 minus negative 2 is positive 6, so 6 squared is 36, and then 5 minus 6 is negative 1, negative 1 squared is positive 1. So it sums up to be square root of 38. Obviously, my diagram is kind of weird because square root of 38 is definitely less than square root of 41, but it doesn't matter. My final distance that I need to calculate is distance between QR. Let's plug in the formula. Negative 2 minus 0 plus 0 minus negative 2 and 1 minus 6 squared. Negative 2 minus 0 is negative 2 squared is 4. And 0 minus negative 2 is positive 2. Positive 2 squared is 4. And then 1 minus 6 is negative 5 squared is 25. So my distance happens to be square root of 33. So obviously my diagram is definitely weird because square root of 33 is the smallest length, but I drew them to be the longest. Once again, it doesn't matter too much, so don't worry too much about it. But so I found the three side lengths of the triangle, and I know that I need to use the cosine rule. So let's plug in the cosine rule. Once again, I'm going to start by copying down the formula from the cosine rule, and because we're finding the angle given the three sides, I'm going to use the second version of the formula. This time, let's look at the formula sheet. I'm going to find in the topic 3 cosine rule. So for the cosine rule, we have two versions. I'm going to use the second version, cosine C equals version. So it is going to be cosine C is equal to A squared plus B squared minus C squared divided by 2AB. So once again, when we use the cosine rule, it is important that we be careful about choosing the correct numbers for the correct letters. In this case, we want to find the angle PQR. So let's call that point C. Then the opposite of the point PQR is going to be the square root of 38, which is going to be assigned as the letters lowercase c. So just be mindful of that. The other A and B doesn't matter too much. So cosine of the angle PQR is equal to C squared is fixed to be 38. So that's going to be square root of 38 squared. And the A is going to be 41 and 33. Divided by 2 square root of 41 and square root of 33. The numerators are quite easy, so let's just fix that quickly. Square root of 41 squared is just 41. That's going to be 41 plus 33 minus 38 repeatedly. And 41 plus 33 minus 38 would be 36. The numerator will be simply 36, which can be simplified into 18 over 41 times 33. Now if I do arccos on both sides, my angle PQR is going to be arccos of 18 divided by square root of 41 times 33. Or inverse of cosine of 18 divided by 41 times 33. So let's put that into the calculator. Once again, in this problem, I don't think the angle was given as degrees. So I'm going to use a default, which is the radian. Arccos of 18 divided by square root of 41 times 33 turns out to be 1.06 approximately. .059, so 1.06. So that is the angle between that is the angle of the PQR. So this is a good example question where we involve the idea of the 3D points in space, where we use the distance and the midpoint formulas. And then we combine them with our trigonometry knowledge about the cosine rule to get the angle between the 2 points, angle between the 2 line segments of a triangle in 3D figures as well. All right, so I think that's good for now. Let's take some time to practice the problems in the textbook that are assigned on the Google Classroom.